293.
Okay, this is section 4.9, Algebra 2, on page 293, roots and zeros. And we're just going to look at some more ideas on how to find roots, what their nature is, things like that. And so we're going to start out with the fundamental theorem of algebra. It's on page 293. You do not need to know it by heart, but it says every polynomial equation with degree greater than 0 has at least one root in the set of complex numbers. Now, the minute I said complex numbers, some of you that were paying attention and actually think about that probably went, you mean there's an imaginary number? No, all real numbers are complex also. So it's just saying that there's roots in every one. Okay? So if we take a look on page 294, here's the type of problems that you're going to start your section out. So it's very important that you understand this. It says solve each equation, and I'm going to abbreviate the directions a little bit here. I'm going to say, it says state the number and type of roots. Well, I'm going to write it out small. State the number and type of roots. Now, if you'll pay attention here, I'm going to give you the roots, the nature of the roots, okay? So when it says the number is like, how many roots? 2, 3, 4, whatever. Your roots are, and I'm going to just use what from there, so I'm going to look so I don't forget any. Here's your possible choices. Real, imaginary, okay, which includes I, and that is it. So you either got real or imaginary. Here's your examples. All right, so let's take a look at number 1. It says x squared plus 6x plus 9 equals 0. Okay, so we're going to try to factor that. You may have to use a quadratic formula. You remember the quadratic formula, or do I need to write it down? No. Okay. This is x plus 3 times x plus 3. And so my answer to the first one is solve each equation. My answer is x equals a negative 3. Okay. Now this one is twice, right? So it's called a double root. This is called a double root. I just want you to remember that. Double root. The number and type of roots are, it is one real root. Now actually it's listed twice, but it's only one real root. Okay? So here is your number and your type. Okay? Now remember, roots are zeros. That's where it touches the x-axis, okay? You understand that? Okay. All right, so let's take a look at number 2 here.
How can you tell, though,
How can I tell what?
that there's only one real root?
Because when I factored it, the negative 3 satisfies both of these.
Okay.
Okay, it's the same thing. So it's a double root, means it's used twice, but there's only one number. Okay? All right? So on this one, you think it's a perfect cube, but you'll notice that this one has an x, Jaws. So we can factor that out. And what I didn't explain in this one is I'm using the zero root property. So if this times this equals 0, either x equals 0 or x squared plus 25 equals 0. There should be an or here. Now, x equals 0, that's a root, right? But I got to solve this one. So I get x squared equals a negative 25. And remember this, and this is really easy to forget, Uton. When I take the square root of both sides, I get plus or minus the square root of negative 25. Most students forget this on the quiz, the test, whatever. Okay? It's easy to do it on a homework when you got 15 problems of the same type. But on a test or quiz, we forget. So this is equal to plus or minus 5i. Okay? All right? I'm going to explain something to you. This has 3 three roots. Now here's the weird part. It has one real and two imaginary. Okay?
I don't understand where you're finding that.
Okay, this answer right here.
Yeah.
Okay, here's a root, and then this one has two of them.
Oh.
Okay, when I factor this and solve and set it equals 0, I got this to be x equals 0. Do you see that, Harper?
Yeah.
And then when I solve this one, I got x equals plus or minus 5i, right? So there's 1, 2, 3 roots. One is real, and two are imaginary.
Okay.
Does that make sense?
Yeah.
Uton? Okay. I want to point out here, anytime that you have an imaginary number, so if you have 2 plus I, they come in pairs. If one of the roots is 2 plus I, you have to have 2 minus I also. These come in pairs. They're called conjugates. And I just want to point out to you, because you'll have to know this later, that whenever there's one, there's the other one. Okay? Do you want to do another one of those, Harper, to kind of get an idea of what's going on?
Sure.
Okay, let's do another. Can I do it over here? All right. Let's do you want to do one like that? Or let's do this one. X to the 4th minus 16 equals 0. This is a difference of squares. So I have x squared minus 4 times x squared plus 4. Does everybody see that? Now I can set these equal to 0, or I can factor this one. It doesn't matter. I'm going to set it equal to 0. So I'm going to say x squared minus 4 equals 0, or x squared plus 4 equals 0. Does everybody see where I got that? Harper?
Yeah.
Yeah, make that a little better. Now I just solve for x. So x squared equals 4. I take the square root of both sides. When you take the square root of both sides, you get a plus or minus 2. If I do it on this side, x squared equals a negative 4. Now I get x equals plus or minus the square root of a negative 4. So x equals plus or minus 2i. Does everybody see where I got that? So basically I have 4 roots. 2 are real and 2 are imaginary. Questions? Okay, now I want to show you something. This is the highest degree in this one, right? How many roots did I have? Well, it says I have one real root, but I really have a double root, don't I? So I basically had 2. They just happen to be the same, right? This says 3. How many roots did I have?
3.
This says 4. How many roots did I have?
4.
Okay, this is the corollary to the fundamental theorem of algebra. It says that this will tell me the number of complex roots I have. Okay? Any questions?
What do you want us to put if we have the double root then? Do we put 2?
You can just put 1 for that. Yeah, I just want you to be aware that it matches that. Okay? Now, I want to show you something. What would happen if I gave you this? I want you to write a polynomial with the least degree with integral coefficients. That means coefficients that are integers that have these given roots. So it has a -3, 1, -3i. In other words, if I gave you this, this, and this, could you find this? If I gave you this, these 2 roots, and these 2 roots, could you find that? All right? I'm giving you these 3 roots. I want you to look at this one right here. If this one is a root, what else must be a root? 3i. Remember what I just said right up here? So even though I gave you only 3, it turns out there are 4. Now, how do you get this? Well, let me show you. And I'm going to have to move up here a little bit. x minus 3 is this, x plus 3, isn't it? If I had this and I wanted to find its roots, I would set it equal to 0 and this would be my answer. So what is 1?
X minus 1.
X minus 1. What is 3i? X, what?
It'd be x squared.
It's x plus 3i and x minus 3i. Okay? But I think you were on to something, Carly. Was it you that were talking?
Yeah,
When I multiply those two together, what do I get?
x squared.
Plus 9. How did I get a plus? Let's FOIL it.
Negatives.
The I is -1.
That's right. Who said that? Good job over there. Minus 3i, right? And then I get a minus 3i squared. These two cancel, so I get x squared, and this is a -1. So minus a minus 3, which is plus, excuse me, this should be 9, sorry. 9. And that's how I got that. CJ, I lost you, didn't I?
No.
Okay. All right, CJ, then I gotta multiply these two together. So I get what?
X squared plus -3.
It's plus 3x. You gotta do this,
Oh,
remember?
yeah.
Minus x minus 3, so I get x squared plus 2x minus 3. You gotta take this times this.
So, x to the 4th.
Yep, and you gotta do x to the 4th, then plus 2x cubed minus 3x squared, and then I bring the 9 through, plus 9x squared plus 18x minus 27. So if I add like terms, I get x to the 4th plus 2x cubed
Plus 5x.
plus 6x squared, isn't it? Plus 18x
Okay.
minus 27. This polynomial has these 4 roots, and we better put that equal to 0, I think. Let me check, I think it is. No, they just say as equal to f of x. Any questions? Okay. So the next part, you're not gonna like, hopefully you'll get better at it. It's called Descartes' rule of signs. And what we do is we create a Rene Descartes chart. That's what we do. A Rene Descartes chart. Rene was his first name. That's what we started calling it a few years ago. The Rene Descartes chart. This is different from your assignment. Your assignment does not have you do a chart. Okay? And so when you check your answers in the back of the book, you'll be confused. And you'll say, this doesn't work. I'll say, yes, because they don't do a Rene Descartes chart. Now, I'm going to read this to you, Harper, and it's going to make no sense whatsoever. But I want you to know this is where it's coming from. It's called the Descartes rule of signs. If you have a polynomial function, then the number of positive real zeros of p of x is the same as the number of changes in the sign of coefficients of the terms, or less than by an even number. And the number of negative real zeros of p of x is the same as the number of changes in sign of the coefficients of the terms p of a negative x, or is less than this by an even number. Have we ever done this before?
No.
No. Okay? I didn't know if we had or not, but I'm on number 5. What I want you to do is to find the possible number of real zeros, negative zeros, positive zeros, and imaginary zeros. So we're going to find the possible number of positive zeros. These are real zeros. Negative zeros and imaginary zeros. Okay? That's what we're going to do. And here's your function. F of x equals x to the 6th plus 3x to the 5th minus 4x to the 4th minus 6x cubed plus x squared minus 8x plus 5. Alright? Now, if there's one missing, you do not put a 0 in it like synthetic division. Okay? You good, Addie?
Yeah.
Alright, so what we're going to do, I read that to you as a joke because what I'm going to do is I'm going to show you how to do this. What you look for is you want to make sure there is one sign between each term. One sign. Don't do plus and negative, please. It just makes it more complicated. I know I've taught you to do plus and negative, but don't do it on this. So I'm going to look for sign changes. What is the sign in front of this guy?
Positive.
Positive. We don't put it, do we? But it's positive. Is that a sign change from that to that?
Yeah.
Well, that's positive to positive. Is that a sign change?
No.
No. So we put an N. Guess what the N stands for?
No.
Alright. Is this a sign change?
Yes.
Is this a sign change?
No.
Negative to negative. Is this a sign change?
Yes.
Is this a sign change? Yes. And is this a sign change?
Yes.
Bo, do you understand what I mean?
Yeah.
Okay. Bo, how many yeses do I have?
4.
4. So we either have a possible number of positive zeros is 4 or an even distance away from 4 going down. Alright, that means I have 4, 2, or 0. Harper, if it's odd, it goes down. Like let's say it's 5, Harper, it goes down 5, 3, 1. So all even numbers go down even until you get to 0, and all odd numbers go down until you get to 1. You got it? Okay, so that's how many positive. Carly? Possible positive. You can either have 4, 2, or 0. Josh, you understand that?
Yep.
Okay, now if you're falling asleep, at least wake up for this part. Now what we're going to do is we're going to replace all the x's with the negative x. This gets kind of lengthy. Let you catch up. Everybody see that? Harp? Utan, how about you?
Yep.
Okay. Tell me, if I take a negative number and I take it to the 6th power, my answer becomes positive. Because the negative times even numbers make it positive. You understand that? Even exponents. Plus, okay, but now, a negative x to the 5th power, that becomes what? Negative. So I want one sign between them. One sign. It's a negative 3x to the 5th. Questions about that? Okay, let's take a look at this one. A negative x to the 4th power is positive, but you got this subtraction sign there. So you have minus a positive, which is just subtraction, right? So that didn't really change, did it? Let's take a look at this one. This becomes a negative, right? But you have this negative also. So what's a negative of a negative? Then you got this one. Whoops, don't want to put that. This is squared, so it is positive, and you have a positive of a positive, which remains positive, correct? And then I have a minus, right? Which is a positive. And then last. All right, do these things matter? No, they do not matter. It's the signs that matter. Greeley? So if you get one of these wrong, doesn't matter. As long as you get the sign right. Okay. Sign change?
Yes.
Yes. Sign change?
No.
Sign change?
Yes.
Yes. Sign change?
No.
Sign change?
No.
Sign change?
No.
Alright, there's how many?
2.
So the possible of negative is 2 and 0. You see that? Alright, now here comes the Rene Descartes chart. This is not in the back of the book. It's not in the answers. They write their answers differently. We do plus, minus, and imaginary. I start out with every combination of positive to negative. So I start out with 4 and then go to 2. I want you to look at the original problem, which is right here. How many roots does this guy have? 6. It's very important. We have 6 total roots, right? All right, so if I go 4 here, and I go with this 2, if I add those two together, I get what?
6.
That means there can't be an imaginary if it's this case. If there's 4 positive and 2 negative, there can't be an imaginary. You understand?
Because they equal 6 or what?
That's because they equal 6, Bo, already. You got it? Okay, now I do 4 and 2, then I go 4 and 0. How many roots is that? That is, how many roots?
4.
4. How many are left for imaginary?
2.
2. Notice these should all add up to 6. You got it? Now, I've completed the 4, right? Some people like to cross it out so they know they're done with it. Let's go to the 2. 2 to 2. Right?
Leaves 2.
How many is that? 4. How many do I have here?
2.
Oh.
2.
6.
Does that make sense? And then I go 2, 0. How many imaginary? 4. I'm done with the 2. Now I go 0. I go 0, 2. How many's left? 4. And then I go 0, 0. No positive, no negative. How many imaginary? 6. You don't have to put this right here. I'm just showing you that it equals 6. All of them add up to 6. This is called the Rene Descartes chart, showing the possible numbers of positive to negative to imaginary. You want to see another one, or you got it?
Got it.
You got it? Okay. Your assignment is page 298. Numbers 17 through 32, comma, 39 through 41. Can somebody put that on the board? You have about, what, 15 minutes to work on it? Okay? I want it done when I see you next. I don't know when that's going to be.
Even if it's tomorrow?
You know what?
No,
If-
so
It would be study hall.
wait.
Yeah, is tomorrow study hall?
Yeah.
Yeah, so it's not due tomorrow, but the next time I see you.
Thursday at least.
At least Thursday. At least Thursday. Okay?
Yep.
All right.
What does it say 17 through 32?
32.